It has examples when they are giving us, when they want us to get the mean and standard deviation of the original population, when they are giving us the sample population. So here the example says the mean sample over 100 observations mean that there our n is 100. So you do add, you read as you summarize. So our n is 100. Observation of random variable x is denoted by x bar. So this mean is denoted by x bar. The mean x bar is, so now our x bar, the mean is 20. Of the sample, this x bar is the mean of this sample. And standard deviation, 0.3. How do we see if it's a mean sample, then our x bar follows a normal distribution with mean mu and variance sigma squared over n. So if this is the variance, we can easily get the standard deviation we want. So our standard deviation is saying our standard deviation is equal to root of val of x. And from here, our val of x for x bar, val of x. This one, val of x bar, is equal to sigma squared over n. But we know that in a normal population, our sigma is the standard deviation. So we can easily first get here, we need this sigma squared. I mean, we need this sigma, so we put there, so our standard deviation will be square root of, now, sigma squared over n, which will be sigma over root of n, which we saw by the way. So we need this sigma, we need this. Now, this standard deviation, they gave us the standard deviation of the mean. So, of x bar. Let me add that. So now this one of x bar, they gave it to us as 0.3. As 0.3 will be equal to now sigma over root of n, which is 100. From here, our n is 100. When we cross multiply, we have 0.3 times root over 100 equal to the sigma. This sigma is the standard deviation of the normal population. And so from there, you can see that our now sigma is 0.3 times 10. So our sigma will be 3. So therefore, the SD of x, the standard deviation of x is 3. This one, they gave us the standard deviation of x bar. This x bar here. So now the standard deviation of x, this is what we got. Then the mean, we say that if it's a sample, we say that the significance, the difference is not so significant between the mean of this and that of the population. So therefore, also our mean of x is going to remain the same as the mean of a sample, which is 20, as simple as that. So this one, be careful of x bar. Okay, so from here, we have another question. Here now they want us to find that sample mean, the number of the sample you are using. A sample of n independent observations is taken from a normal distribution with mean. So this one, the normal distribution there, our mean, they are telling us that it's 74. And standard deviation, so our sigma now is 6. This is now a normal population. With mean, a sample of n independent trial is taken from a normal population with mean this and SD 6. If the sample mean is denoted by x bar, find n if x bar is that. So they are telling us that our x bar is greater than 75. It will be 0.282. Here we are going to use some normalization because they are giving us a probability. Now, this 6 is the sigma we want. So, because now this is the sample mean, now we standardize it. So our z will be greater than, get 75 minus the mean, which is 74. The whole over the standard deviation, which is 6. of this, then square root of the sample which we are looking for. And this one is telling us that is 0.282. So now this will be the probability of z greater than, that will be a 1, which we can easily get the reciprocal. 1/6 root n equaling to 0.282. Now if we treat this as probability of zp equaling 0.282, now we need this value, never this value, that's going to be equaling to the whole of that. So we come and we do a simple sketch here. So they are telling us that this is now standard normal. We want, because this is greater and this one is smaller than 0.5, then it's always at a positive. If it's bigger than 0.5, then it's decided to be the negative. But because it's greater than z of this we want, and it's below 0.5, then it's decided. So they are giving us that probability here. They are giving us this probability. Remember, if this is p, then this one is 0.5 minus p, because we said the sign is 0.5. Now it's that they are giving me this probability, that is this. So meaning 0.5 minus p is equaling to 0.282. What am I looking for? I'm looking for this value of z, so that when I get this value of z, will be equaling to the whole of this. So I'll be having 100n as the unknown. So from there, if you subtract, our p will be equaling to, so 0.5 minus 0.282, I get 0.218. Now this value, we have the probability, now we are looking for this value of z. We go to our tables and look for that value. And we are going to show you how I'm getting that. But we have seen that. Okay. So the value we are looking for is 218. And you see, when you come into our table, the value that is pros is this. But you start the difference here. When you get to 218 and you subtract off this value here, the difference is going to be 23. So our difference is 23. This is what I'm talking about. When we get 80 minus 2157. So this is what I'm talking to. This is what I'm talking about. When we get, is that the closest we can get is that this is the value we have, but we want this. Is that the difference we have is 23. So meaning we only add. I can't use this one because this one is already exceeding. But here they are telling us we only add. That's why I'm going to go. I go now. So it's that this one is now in. I have 0.5. Then this value here is under 7. Now I need to add 24. Where is 24? So I move in that line. So this one is, I need to add 23. But so the value which is closer to this is that this one is 21 and this one is 24. Which one is closer to 23? 24 is closer to 23 than 21. Because this is 21, you have 22, you have 23. You see that we are missing, but from here you have 24, then from 23 it's just 2. So now we are going to add this 24, but it's under 7. That's why I'm having this. So meaning that this one is going to be our ZP will be equaling to that value. So that's why it's going to be 0.577. So now we have it there. So you know that now from here our probability of Z greater than 0.577 will be equaling to 0.282. But remember, this was this. So implying that our 1 over 6 root n is equaling to our ZP equaling to, now the value we got, which is 0.577. If you compare this and this, you start this one is equal to this. So, meaning this one you can get the square, the reciprocal to have root n over 6 is equal to 0.577. Because compare and get the square root. R root n will be 6 times 0.577. And so our n will be the square of this 7 square. So our n here, when you read that, when you square that, we shall be having 6 times 0.577. Then when you square that value, we get 11.9854. So our n is approximately, we give the next integer, which is 12, and that will be our n. So the sample. So I think members, you can take on part B, where they want us to get x bar, the value of n. If x bar, we have 70 equaling to 0.0037. I think we can take on that. I'm going to leave it on the way to standardize this. We have now z less 0.4, then minus our minute is 70, the whole over 6 over root n equaling to 0.0037. So this is the probability of z less when subtract. There we have a negative, I think. Okay, so I think this is going to give us negative 3.6. You can always simplify this 0.03037. And so, if I handle this, now I replace this with ZP, so I can just read it from, can give you a clear interpretation. When you have that, now it's that I will draw so that you can see where it's going to come from. You see that this one is 0 point, be less, means that if it's to be this side and we are dealing with this, it should be greater than 0.5. But if it's less, it means that this speed we are looking for is now in the negative. That's the interpretation. Now the probability is here they are giving us. But remember, this is P, then this one is going to be 0.5 minus P, because we said all of this is 0.5. So from there, that R 0.5 minus P, they are giving us this as the probability 0.037. So our P there will be 0.5 minus 0.0037, which is 0.4963. So now my anti-Z of this. Now the negative, because this is negative, that's why I am adding the negative. The answer we are getting, if I read from my table here, the answer I'm getting is 2652. 2.652 after reading from the table. So meaning that our ZP will be negative 2.652 after dividing the two. So meaning that the whole of this, so meaning that the whole of negative 3.6 over 6 times root n. Okay. Root n is equal to our ZP. Our ZP is then negative 2.652. So if we simplify that, so this can divide this and we get. So simplifying that is that if we get the reciprocal, we have negative that can divide that. This divided this to get negative 0.6. Then get the reciprocal root n equal to negative 2.652. And so there, my n will be, you square and you divide. So if you do that, 5 2 divided by square that, we get 19.5364. So that our n approximates the next integral is 20. So that's how we handle those two members. I wish you well.